Okay, so today we've got Skulk in the house and we've got Xandor to educate us on all the things. Super duper exciting stuff, functional programming in React. Skulk, would you like to introduce Xandor? You know him better than I do.
Yeah, I'm more than happy that I didn't prepare anything, but yeah, here we go. So I think I mentioned this last time. So I think the last talk that you did, Xandor, was design systems, if I'm not mistaken.
I think so, yeah.
And I think I mentioned it last time as well. Is that and there's a reason why I also made a point of actually joining this specific one tonight, even though we had one last night and we had one like an event last week as well. So I'm overdue for a lot of nappy changing time. My wife's probably going to cash it in on the weekend, but like I really like there's a certain like thoughtfulness that I find that you kind of bring to your thinking around the front end and JavaScript and so forth, which I think is I find like super refreshing in the kind of the front end space, especially when people are arguing over like, oh, this tool's the best, that tool's the best. It's very rare that I see you actually post anything on ZA Tech or anywhere, and I don't find what you shared like super insightful. Doesn't always mean I agree, but I do appreciate like kind of there's a very methodicalness and thoughtfulness in the way at which you kind of arrive at like your opinions and so forth, which I really appreciate. But yeah, so if I haven't made you super awkward already, like I can keep going. But yeah, I just want to say like I really appreciate that, and also your willingness to kind of do so many of these talks and kind of share that. Sure. You, as far as I understand, you're going to have to do a better intro in terms of what you're currently doing at the moment. But I think you and Mike also work together at the moment for Operativa, or is that not the case?
We're in the same Slack workspace, but we're on different projects, unfortunately.
Okay, and that's maybe a really good segue to our sponsor. Mike, do you want to give a word about the sponsor?
Yeah, it'd be great if I prepared something.
Yeah.
So should we chat about the recurring Fedsa sponsors, or we just?
I'm fine. So the React stuff is mostly Operativa. So previously Vulkan Labs, but kind of some of the folks that were most involved in that kind of moved on to Operativa. So they're kind of the primary sponsor at the moment. And Mike, you're also part of that team. So I think you guys don't yet have like a logo or any collateral.
Yeah,
or
we're
anything.
very young.
Yeah, I don't think you even have a website. Yeah.
Yeah,
So,
I don't think it's live yet. It's being worked on.
Yeah.
But yeah, kind of things were formed around 1st of Jan. We managed to convince Xandor to join us, and yeah, the objective is to build platforms. It's pretty exciting stuff. Feels weird to plug where I'm working at, but yeah, I started doing this before I started working for them. And it's a nice place. Smart people like Xandor work there. So yeah, I think this is feeling really meta, but thanks to Operativa for allowing us to do this, and helping us source speakers and make sure that speakers are incentivized for their time, and helping Fedsa do more stuff. That's a pretty cool initiative, and I'm grateful that I'm able to contribute to that.
Also, like, there isn't a website or anything. Is there anything online where people can learn more about you guys? Or okay, so
just like creep on us on ZA Tech. That's
like the big reveal is coming.
Yeah, I mean that's not
No
setting expectations there.
So yeah, but like that's the best you're going to get from us, Xandor. So I think from here, like, you're probably more qualified to actually give a bit of an introduction in terms of who you are. And what I also, from my side, what I would also like, I think find super interesting is what draws you to functional programming, which is always for me like a really interesting conversation to have, because it's not the the common journey when it comes to software development and so forth. That more so nowadays, but it seems like it's speaking for myself as well. It's more or less like one goes on kind of a bit of a tangent into the world of functional programming. So I'd be curious how you ended up doing that. But yeah, happy to hand over to you and let you do your own introduction.
Okay. So I'm Xandor, and I'm a React consultant. Pixel Theory is my own company, and I also don't have a website. Despite having been around a lot longer than Operativa, there's absolutely no excuse. Cobbler shoes, so they say. That is actually a link. It goes to a domain I own, and it won't resolve, but maybe one day it will, right? So it's in there. You can find me on ZA Tech. I'm at Xander, on Mastodon, Xander at IndieWeb, and Twitter at Xander. I'm not really super active on kind of public social media, and I'm actually doing what do they call it? A digital declutter. I'm reading Digital Minimalism at the moment. I'm also taking a bit of a break from ZA Tech. If you message me, I'll respond, but I'm not actively hanging out in channels at the moment. I'll put it back in. So I've been developing for the web since 1999. I was 13 when I made my first website. It was glorious. It wasn't actually hosted on GeoCities. I was using a host called FreeWebs. It was the pinnacle of web design. There were under construction signs everywhere. I had a large, obnoxiously green Comic Sans font on a black background. Yeah. and I grew up with the industry. I even got some work doing web design stuff in high school, and I carried on with it. I spent some time in digital agencies. That was really cool. That was around the time that HTML5 and CSS3 were just a thing. And from a JavaScript perspective, I call it like the Cambrian explosion of JavaScript. That's when V8 came around and it really became fast. And all of a sudden, it wasn't just like this toy scripting language anymore. You could do real things with it. So I cut my teeth on that. I've been hanging up my own shingle, consulting for clients like Operativa since 2014. So I've worked for various different kinds of projects. I'm technically a full stack developer. Like I started with PHP, don't hate me. But I have spent the lion's share of my time in the front end, and I do really enjoy it. I really love the design aspect of it as well. I'm like that one dev that if a designer comes to me and complains about something being a pixel off, like I am just as bothered by that as they are. Okay, so enough about me. So functional programming in React. What are we going to talk about today? First of all, what is functional programming? This talk is aimed very much at, if you know absolutely nothing about it, you'll be very at home here. You don't have to have any background. We want to talk about how React is related to functional programming. And then we're actually going to show some code examples. These aren't live code examples because I'm not that brave, but this code does work. Right. We aren't going to cover some more advanced topic like monads. Some of you may have heard about monads and monoids and functors, and there's that joke where it's like, oh, a monad is just a monoid in the category of endofunctors. What's the problem? We're not going to cover any of that. It's not actually that scary. It's just that the mathematicians got there first, so they got to name everything. But we're not covering that today. So what is functional programming? This is paraphrased from Wikipedia. The style of programming where programs are constructed by applying and composing functions. So this is your fundamental Lego block that you reach for whenever you're trying to do anything. If you're programming in a functional way, you reach for a function. You wouldn't start by reaching for a class or a method. You would reach for a function. So there are some things that are core to functional programming. This list that I'm going to give you is not authoritative or exhaustive or anything like that. There are some people who only consider your functional programming as if it's like the distilled essence of the universe or something as the only true functional programming. Then there's other people who have a bit of a broader view, and then there's some other people who just like mixing in some functional programming with what they do in their in the rest of their code. They might have a predominantly OO code base, but like using functional stuff inside of their methods, and that's all fine. That all works. But some of the hallmarks tend to be pure function. So what does that mean? Pure function is a function in the mathematical sense, which means it's a mapping from one range of values to another. It will always give you the same result if you give it the same inputs. Software functions can do that, but they don't necessarily inherently always behave that way. You can write functions that aren't pure, that may do something different, even though you're given the same inputs. An example might be a function that reads some global variable, or that reads from a file, or that does anything to do with dates, or randomness, or user input, or databases, and so on and so forth. Input-output generally is a good sign that something non-pure is going on, and that's fine. So when I first got into functional programming, I was so confused because there was such an emphasis on pure functions being the core of it, right? That's what the functional in functional programming stands for, is these pure functions. And what that also means is that your pure functions don't have what are called side effects. So side effects is anything that isn't part of a pure function. Things like input and output, things like writing stuff to the console, that kind of thing. And I'm kind of sitting there thinking, okay, but how do you get anything done? You don't have these side effects, right? Because what are you doing? So the truth of it is that all functional programming languages do allow you to do side effects. Otherwise, all you're doing is making your chip warm, and there's like no point to that, right? Even Haskell, which is mathematically provably a pure language, has side effects, and it cheats. And the way it does this is by saying the language itself is pure, but the runtime is not. So the language hooks into the runtime, and that's how it manages to do side effects. Okay. Enough about that. Immutable data. So this is another one that I'll get into a little bit deeper just now, but immutable data is this idea that you don't mutate your data. In conventional imperative or procedural programming, you may have a variable that you change over time as you're doing stuff. Maybe you're keeping track of something. Maybe it's a counter. Maybe it's an index, what have you. You might update this value as you're doing some kind of useful work. So you're mutating that value. In functional programming, we tend not to do that because although it's convenient and although there may be performance benefits to doing mutation rather than an immutable approach, it's very difficult in the large over time to be sure that this data that you're dealing with is actually still the data that you think it is. Because if it's mutable, some other piece of code could have changed it, or in many cases, some other piece of my code that I forgot about changed it. So another thing is that in functional programming, you can technically do functional programming without first-class functions, but it's incredibly difficult and it's very, very limited. So you wouldn't want to do functional programming without first-class functions. What first-class functions mean is that a function is also a value, just like a number or an object or an array. And what that means is you can pass it around. You can assign it to variables. You can take a function as an input, as a parameter to another function. Or you can return a function from another function, right? So it just means that you can pass them around as if they were other values. If you can do this, you get what are called higher order functions. Higher order functions are functions that either take functions as parameters and or return functions as their return values. And then this is very, very cool because you can do a lot of composition with that. And we'll see a little bit of that later. The second thing is that, okay, so in pure functional programming, you don't have statements. A statement is a piece of code that does something but that doesn't return a value. In pure functional programming, you only have expressions. Any expression evaluates to its kind of return value, right? So that means no if statements. It means no try catch, no throws. It means no while loops, no for loops. It means, yeah, kind of all of that. Kind of nothing that, like an exit call wouldn't be a thing. No statements at all. And there are ways to get around this, and there are good reasons why you might want to. It's not as unergonomic as you might think, but it can be a little bit weird to think about. Later on, once I got used to this idea of having expressions everywhere, it was great, because the reason why functional programmers don't like statements is because they're not as composable as expressions. Because an expression you can replace with the value it evaluates to, which means it's easier to swap stuff out. A statement is not so ergonomic. Recursion. So this is how would you loop in your code if you don't have a while loop or a for loop or a for each or a for in or any of that. You do it using recursion. Recursion is a function that calls itself. You may have come across this in kind of coding boot camps or other kinds of coding exercises. A common example is the Fibonacci sequence. Calculate the Fibonacci sequence. That same function takes its output as its input and calls itself again with its own return value until some limit is reached. That's what recursion is. Right. The benefits of functional programming. Like why would we care about all these restrictions, right? What's the point? So when a function is pure, it always gives you the same result for the same inputs. It means it depends on nothing other than its inputs. And that makes it really easy to test. You basically don't need to mock stuff. You don't need to spy stuff. You just give it a value and check that it returns something. Super easy to test. It also means that the function has a clean contract. It doesn't do spooky action at a distance, which can be convenient sometimes. But when there's 50 of those things happening in a large code base, it's not convenient anymore. Wow, nice spelling error. It's easier to reason about because its API surface is right there in front of you. You don't have to really keep as much context in your brain in order to understand what a function is doing, because all you're concerned with is the definition of the function, its function signature, what parameters am I getting, what work am I doing inside this function, and what am I returning. That's it. You don't have to worry about the rest. Yes, those parameters come from somewhere, and yes, that value that you return goes somewhere else. But while you're working on this function, that's all that matters. You don't have to have more context. There's this commonly accepted kind of like truism about brains that it's we can hold I think 5 things in our mind, plus or minus 2 either way, depending on how clever you are. And also it's very much not just genetic or anything, like you can practice this, but there is nevertheless like a hard limit to how many things we can hold in our mind. And this is a quote that I got from a podcast called LambdaCast. And one of the hosts in that podcast says, people always tell him that, I don't understand how you can do this functional programming. I'm not smart enough to do that functional programming. And he says, I'm not smart enough not to do functional programming, right? So kind of alluding to this idea that it's a little bit easier to grapple with because it's a lot clearer, where the thing you need to be concerned about begins and ends during any coding task. So you also get better modularity, the fact that there is less spooky action at a distance, that when you do have side effects, you treat them with a certain amount of discipline. It's easier to swap things out, especially when you get into things like monads. These are also called algebraic data types. There's a lot of modularity and composability there. We're not quite going to get into that today, but maybe just take it on faith. you can get really far with that. Yeah, so that leads into more code reuse and fewer bugs, because it's easier to test, because it's easier to keep everything in your mind, because there are cleaner contracts. You tend to end up with fewer bugs, at least per line of code. On the other hand, functional code tends to be really, really dense. It does a lot with a little, and that actually can be a little bit overwhelming in the beginning when you're expecting to get a certain speed of understanding per line of code, and then you start reading functional code and you're like, why is this hard? There's so much going on. And a lot of that is to do with familiarity. After a while, it becomes a little bit easier to know what a map is doing, what a reduce is doing, for example. Okay, so JavaScript is a multi-paradigm language. It supports many styles of programming, including functional programming. But most people, I think of JavaScript as something that kind of can do functional programming, not something that is kind of has a functional heritage, and it actually does, right? So we'll talk a little bit about the history of functional programming. It started long ago in the midst of time. I forget the exact dates. I was going to pull up the Wikipedia page and I haven't. But I think it's in the 40s and 50s. There was a mathematician called Alonzo Church. And Alonzo Church was looking into kind of really the underpinnings of mathematics and trying to kind of derive mathematics from first principles. I don't know if you know much about mathematicians, but this is a thing that they like to do every few decades. Like right now, there's a big hoo-ha about homopathy theory and infinite categories of infinities. And apparently this is what maths is going to be based on. My poor kids, that they're going to have to learn this stuff one day. FYI, right now, we're basing it on set theory, but there are limits. Anyway, the lambda calculus is a very, very simple way of thinking about operations that works kind of completely on substitution. And we don't have to get into it too deeply, but that's what functional programming really is based on. Incidentally, that's where the lambda from, for example, Java comes from, where it stands for an anonymous function, and I think it also does in Python. It's from this lambda calculus. Like a lambda is one of these functions where basically it does some kind of substitution. There's an example later on where I can kind of point this out, how that might work, called beta reduction in the lambda calculus, but just think of it as swapping out values. Yeah, the first true functional programming language is Lisp, which stands for list processor. And it was initially created to help computer scientists do research in artificial intelligence. It is not currently one of the bigger languages used in that endeavor, but at the time, it really, really was. And Lisp is interesting. It's a very interesting language, and you really owe it to yourself to learn a Lisp at some point during your career, even if you don't do it professionally. Like even beyond just the functional programming stuff, like Lisp, for example, the data structure that is a list, which it's kind of like an array, but it's a list in Lisp. That same data structure is how you write the code. So the code can operate on the code, which can do some really powerful stuff, some really powerful, hard to debug stuff. After Lisp, at some point came Scheme. I'm really paraphrasing here. Like, you can look this up on Wikipedia if you want. Scheme is another Lisp. And Brendan Eich, who's the person who created JavaScript, was a computer programming language nerd. Like, he loved this stuff. And he was a big fan of Scheme. And he was hired and enticed away from his academic career to go with the promise. Netscape promised him that he would be implementing Scheme in the browser. JavaScript was supposed to be a Lisp. This didn't end up happening because it was the .com boom, and there was a lot of startup-y stuff happening and a lot of synergy that they wanted to have with another language called Java. So he was told to kind of, sure, do what you want, but make it look like Java. And oh yeah, you have 10 days to finish the demo. So So, and that's the kind of V1 of JavaScript-ish. It's not technically the V1, but like that we were stuck with. And there are a few warts in JavaScript as a result. Incidentally, there's another language called Self, which is what the object-oriented stuff has come from. Yeah, and that's how we get to JavaScript. So the fact that JavaScript has anonymous functions, effectively lambdas, that it has first-class functions, is all thanks to Scheme, and that is why it is well suited to functional programming. Okay, so let's talk about a few functional programming concepts that are used in React. Now, I think React does a pretty damn good job of not like really needing the users of React to understand all this stuff in order to do a good enough job with React, and that's great. I think it has done a lot to slowly, by osmosis, bring functional programming more into the mainstream. But the React's kind of core thing is they're the V in MVC. That was the original pitch way back when. They're just they were initially meant to be just a view library. And the whole idea was that the view is going to be just a pure function of the state. And perhaps now that we've had React for so many years, this seems like a duh kind of statement, right? Like, of course, that's how views work, right? You take the data, you give it to the view, and then you get the thing. And if you give it the same data, you're going to get the same view every time. Things didn't used to be this way, because what we used to do is we used to mutate the DOM imperatively, and if you did A, B, and C, you might get a certain state. And depending on what those steps were, if you did A, C, and B, you might end up with a different output. And it wouldn't have been what you expected in terms of what your UI would look like. And anywhere these types of operations were interacting, which means anytime you were composing anything, you ran the risk of that happening. So React really, really made our lives a lot easier by bringing this paradigm to us. So the idea is that every time you give it the same state, you will get the same view. As a result, React is very declarative. It ends up kind of, you don't use React to kind of fine tune what exactly is happening with the DOM. You don't say like tweak this a little bit here and do this a little bit there. You just say to React, this is what I want it to look like, right? And React will make that happen for you. So any type of programming that is declarative is like that. You say what you want the end result to be, rather than how you want that to be achieved. Like SQL is another declarative style of programming. CSS is, for the most part, also another declarative style of programming. Instead of specifying the steps, you specify the end result. So if done well, this means you don't have to think about the how. You only have to think about what you want. Again, React works a lot with immutable data in the sense that React uses what they call the kind of referential identity of a lot of data to tell whether something's changed or not, right? The idea is, in many cases, if some of your data has changed, you should be creating a new object to contain that, whether it's an array or whether it's an object or whatever the data is that you're dealing with, right? That should be a new array, because if all you did was mutate the data, then as far as React is concerned, that's still the same array. Sure, there's different things inside it, but it's the same instance, like the same array. It's the same location in memory where that array starts. And that's what React is checking for, is has it changed or not, in order to determine whether or not it needs to do any work on your behalf. And that becomes a lot cheaper than comparing all the actual values. So that's part of the contract with React is, hey, you do the immutable data thing, and then we make DOM updates really easy and fast. And that's, again, where the virtual DOM comes in. So I mentioned here structural sharing. So I don't know how many of you in the audience know exactly what the virtual DOM actually is and how it actually works, right? So I guess to talk about that, I first need to talk about what the DOM is. The DOM stands for the document object model. It is a way to represent the actual document that's being rendered in the browser using a model of objects, specifically in a tree structure. Each of these objects represents something that's usually something that's actually being drawn onto the screen. But it's kind of expensive because I don't know if you've ever looked at your browser dev tools at some of these. Oh, hey, I don't just went dark for some reason. I don't quite understand. Anyway, I don't know if you ever looked at your browser dev tools and looked at what types of properties and methods there are on a DOM element. Like even for something as simple as just a div, it's hundreds. So for each DOM element that exists, that has to be created and has to exist in memory, and it has to be instantiated, and it has to have relations to some of the other stuff, and that just takes time and memory. So the virtual DOM is like the DOM, except it's just a plain JavaScript object structure of elements, and it's very much simplified. It has very few extra properties compared to the ones that you specifically as the programmer care about. And what happens when some of your state changes, React gives that state to all the components in the component tree, and it asks them to render, which is to actually give back an object representing, again, React's simplified model of what the DOM should look like. And if that's the same as before, because the data hasn't changed, it doesn't actually re-render. It just says, okay, cool, the inputs haven't changed, so I'm just gonna reuse the results I had from last time. And this is what structural sharing means. It's possible to have objects that are in more than one container. I mean, think about it this way. Think about you have 3 objects, A, B, and C, and you add them all to array number 1. You can add those same objects to array number 2, right? That's kind of what's happening with structural sharing. It's like that. I don't want to spend too much more time on this. Hooks. So hooks are based on something called algebraic effects. And this is actually amazing because algebraic effects is still very much an area of active research in the heady places of computer programming language, academia, basically. So the fact that the React team was able to bring this out and make it so accessible for us is actually nothing short of amazing, because algebraic effects are everywhere else in the programming world kind of confined to literally research languages, something like Eiffel. And I think there's now a few language extensions in Haskell where you can kind of start playing with this. But we've just had it for a while already. JSX or create element. For those of you that don't know, JSX is, I know it looks like HTML and JavaScript. It's not. It's all an illusion. It's syntactic sugar for the React create element function. If you have a look at the React docs, you can use React without JSX, and that means you'll be using the create element function. And the way it does that is kind of like with a nested set of function calls, where you have create element and a component and its properties and its children. And then those children is a create element call, the component, properties, and its children, and so on and so forth. And that's called S expressions. And that comes from Lisp. Lisp did it first. Literally, the way a list function is expressed is as a list. That is an S expression. So it borrowed that as well. Use reducer also comes from functional programming. A reducer, technically a reducer is a way to transform a collection of values into another value. That value can also be another collection. But that's what a reducer is, and that's what we use it for. We use a state that exists plus some input, and we give a new state. Use effect as well is, so this comes from the algebraic effects way of doing things, but the reason I mention it separately here is because it is a disciplined way of dealing with side effects. We have some ceremony around it. We have some safeguards around it. We isolate it from the rest of our logic of our program. We try our best to have a relatively clean contract with the rest of our code. And as a result, most of our business logic is separated from the effects, and that makes it easier. At first blush, it's easier to do effects just somewhere like as you're doing business logic. It's convenient, put it that way. But very quickly, everything's so tangled that when you start needing to reason about the interaction or the order of these kinds of things, it becomes very hairy. So use effects helps with that by being so explicit about what influences a particular effect. Right. So let's get into some actual code examples. We've talked a lot about history and concepts and ideas, but what does it mean in code? Right, so the first thing I want to talk about is a pure function. So this example here is not a pure function. It's an example of an impure function. I'm sure this is a toy example, but you may have seen echoes of this in real code. We have a mutable variable, and we have a function that interacts with that mutable variable. It both reads and mutates that mutable global variable. So if I call increment x once, we go from 0 to 1, and it returns 1. I call it another time with the same input, which is to say no input, but which is the same as before. And I'll get a different result, right? So depending on how many times I call this function, it does something different. Sure, its internal logic is the same, but the result I get changes depending on when this happens. And that means now I have to, with this kind of code, keep in mind the order of operations more. And I have to care about that. And that's not fun. I would like not to care about that. I would like for that not to matter. So imagine a different function that is a pure function where I don't mutate anything. I take an input, I do something with that input. Well, rather, I use that input in an operation, and I give something new back. So if I run increment with x, which is 0, once, it'll take 0, and it will add 1 to it, and I'll get 1. And if I do that again, it didn't change 0. I'll still get 1, and I'll still get 1, and I'll still get 1. But this is great. This means I'm less worried about what's happening with the order of my operations. It's not like it doesn't matter at all. Clearly, sometimes you have to do certain things before other things because that's just how logic works. But you're affected by it less. Incidentally, if you want to look at, remember I said that the lambda calculus was just substitution. So this here is technically a lambda. If I take num and I just substitute it, that's how the lambda calculus works. So this is for a simple function. Here I'm plugging 0 in. It takes 0. Okay, cool. Look for all the occasions where I see num. I replace them with 0, and then I evaluate the resulting expression. And that's how the lambda calculus works. That's incidentally how all of computation works. Modern computers are not based on the lambda calculus in terms of how the actual silicon works. They're based on this thing called a Turing machine. That the von Neumann architecture is another mathematician who implemented Turing's machine. Alan Turing was the person who came up with a kind of a modern model of computation. Incidentally, Alonzo Church, the guy who created the lambda calculus, was Alan Turing's doctoral advisor. And they published a paper proving that both systems of computation are equivalent. Which also means that sometimes people ask, okay, but what is functional programming good for? And I'm like, well, it's good for everything. Because it's functionally equivalent to imperative code or object-oriented code. Anything that is computable with object-oriented code is computable with functional programming. Now, you should think about it a little bit more deeply than that, because technically speaking, the weirdest things are Turing complete. Excel is Turing complete. I think there's probably window managers that are Turing complete. SQL is Turing complete. You probably wouldn't write whole systems in those languages just because you could. So that in and of itself is not enough. But it's interesting to note that long ago, they proved that this was equivalent. Incidentally, there did used to be machines that at the silicon level were functional machines. These were called Lisp machines, but they never really took off. Yeah, let's talk about higher order functions. Remember, I said a higher order function is a function that can either take a function as an input or return a function as an output. So let's imagine we have a function called add, where we take two numbers, x and y, and we add them together. So the highlighted line right now, that is how we might ordinarily, conventionally write such. Imagine if we wrote it like this instead. Now, when I saw this the first, oh gosh, must have been 50 times, it confused me every single time. I'm like, what's going on? It was just so alien. I couldn't grasp it intuitively in any case. Now I can, now I'm used to it. But at the time, I had to like really model this in my head, like what's actually happening every single time. So let's take it bit by bit, right? I'm finding a function here, right? This is and you'll see all throughout my code examples, even for single argument functions, I've included the parens, and this is just to make it easier to see that we're defining a function. Because for single argument functions, for single argument arrow functions in JavaScript, you can leave out the parens, but these variables just look a little floaty. They look more like they belong in the function of a body. So I didn't want to go for that style for this talk. In any case, so what I'm defining here is a function takes one argument, x. And what that returns is another function. The function that it returns is a function that takes this argument, y. And it does this. It adds x and y together. So you would use it as follows, right? Which looks a little weird, right? First, I'm calling the first function, the one I defined here, right? And then that returns this function, and I'm calling that function there. And as soon as I do that, this body actually executes and it returns its value. And in this case, I get 3. So, and this is one of the things that's a little bit, first, it seems so limiting and cumbersome in functional programming. As a result, in functional programming, we're typically quite concerned with what we call the arity of our functions. And all that means, it's a fancy mathy name for how many arguments our function takes. But we're specifically talking about like really how many nested functions we have and how many single arguments of those nested functions our kind of compound function here ends up taking. So the arity of this function is 2. It takes 2 inputs. Some functions have an arity of 1. Those have a special name. Those are called unary functions. Right. So there are actually utilities out there that you can use to wrap these kinds of functions in such a way that you could still call this as if it had been defined like this, if you wanted to, or optionally call it like that. That's called auto currying. And defining a function like this is called currying. It has nothing to do with the delicious food. It has named after Haskell Curry. Haskell Curry was a computer scientist and mathematician. I think he was also a computer scientist. I stand to be corrected. Who not only had currying named after him, he also had the programming language Haskell named after him. So yeah, there you go. In some pure functional languages, this is kind of like the only way you can define functions. Like you wouldn't be able to have 2 arguments inside like here. Well, you could if you gave it a list or an array, but you'd have to explicitly do that or a tuple. And what you can do with this, right? And here we get to the higher orderness of stuff, right? Instead of, because this seems cumbersome, like why would I want to do this? Why would I want to have extra typing just to have a function? That seems a little bit silly. And if that's all I wanted to do, yeah, that would be silly. But what we can do is I can take this add function and only apply the first argument. This is called partial application. So I'm not saturating it, right? And then what I get back is this other function, this one, but it's like preloaded. Like this x in this increment function has been already set to 1. It's been preloaded by calling this part first. So now I have this increment function here, like I put it in the comments, is actually functionally equivalent to y returning 1 plus y. And that's pretty cool. Like I could make, I don't know what the mathematical word is for adding 2. I don't know if there is one. Right, I could add -1 and actually make it a decrement function, and I could have a whole bunch of them around. So by having this currying style of defining functions, I actually have lots of little function factories, and I can create functions easily and combine them later. We'll get to composition in a bit, right? And further on here, let's call increment, give it 2, and it does 3. And the reason that happens is because we're turning y into 2. We have already set the one before. We're adding 2 there, and that makes 3. So that's partial application. Okay, so what is all this good for? And this is kind of where the power of functional programming comes in. You get to use all these little libraries and these little functions, and most functional programming languages come with huge standard libraries of lots of these functions that you can use. And in many cases, for like 90% of your program, you're doing very little else other than just composing these pre-existing functions. In JavaScript, unfortunately, the standard library is kind of small, shall we say, compared to what it could be. And as a result, there are actually lots of third-party projects that help out with that. Lodash, for example, is one of those that kind of fulfills that purpose. And we'll talk about that a little bit more later. But let's create a function that turns the string world in normal sentence case into all caps, hello, comma, world, exclamation point, right? A different case. So each of these operations that we would need in order to change, and let's assume that we might want to use a different string and go, hello, John, or hello, Jane, or hello, cupcake, what have you, right? So we can't just kind of hard code world into there. So we would need a series of operations to do this. And we can split those out. We could write it all in one function, and then that function would only ever be good for this one thing. Or we could write a whole bunch of different functions. So let's imagine we define a function called shout, which takes a string and then calls to uppercase on that string for this uppercase stuff. Then another function, concat, which is short for concatenate, which is a fancy mathy word for saying squish things together. We have string A and string B, and these are defined in that currying style, so they can be partially applied. And it just returns the combination of string A and string B, the concatenation of those strings. Then greet, which, see, we're partially applying concat to get greet. We're saying, okay, cool, fill this first argument with hello, comma, and a space, right? And that means that what this returns is this bit with string A set to hello, comma, space. The next function is emphasize. And what this one does is kind of the same as greet, except we're setting the second argument first. So it takes a string, it takes a string and returns this. So you still need to call emphasize before you're doing that. So you kind of like it works in a different way, but you're swapping it around. And in many of these functional utility libraries, there are other utility libraries that will kind of do that for you, so you don't have to do it so mechanically and explicitly as I did it here. Swap the arguments around. So if we call greet with world, we are taking concat hello, and adding hello world. So if you look here, that is hello comma and world, and that gets hello world. If we do that again, but we wrap it with emphasize, and remember emphasize appends, right? Then we took hello, comma, world as this string, and we gave it to concatenate, and we added an exclamation point, and that's what we get here. And then if we shout, that just takes any string and uppercases it. So that was what we end up getting. So we can compose functions. We can call functions one after another. We can take the output of one function and give it as the input of another function. And as long as those functions expect to operate on that type of data, we can do this all day long. And here we're just working with strings, but it's possible to turn a string into a number and a number into an array and so on and so forth. And if those types line up, if the Lego studs of these functions fit, then you can compose them together. But writing it this way, is confusing because you have to, like, the first operations in the middle, we have to kind of read from, it's kind of right to left, but it's kind of like middle to left, right? I'd much rather read from right to left, so from left to right, sorry, from left to right, or from top to bottom. So there is a function called pipe, whose definition is here as an exercise for the reader. I'm not going to go through that. Let's just assume that it works. It does work. You can read that code and figure it out for yourself if you want. But for the purposes of my talk, we're going to trust that pipe works. What I can do is I can take greet, emphasize, and shout, and pipe will turn this into a new function that is expecting one argument, and we'll call these in sequence. It will take the input, call greet on it. It'll take the output of greet, give that to emphasize. And it will take the output of emphasize and give that to shout. So I have the function that this returns, I have assigned that to salute. And if I call salute with the string world, I get hello world. And in this way, we can compose functions. There is actually another kind of function like this called compose, which is exactly the same except for the order of the functions. It goes from bottom to top, which is mathematically more accurate, but for the everyday programmer, less intuitive. You might be happy to know that there's an ECMAScript proposal out to add an actual, honest-to-God, built-in operator into the language that can do this. It's unfortunately been at stage 2 for years. So maybe one day, holding thumbs. Okay. Another thing that is core to functional programming is immutable data. So, okay. So let, when you declare a variable with let, it means it's mutable. It means you can still change it at some point later on in your program. So when you're programming functionally, don't ever use let, because that allows you or someone else to mutate your data out from under you. Instead, use const. Const, when you use const, the JavaScript engine will make sure that you can't reassign that variable. If you try, you get a type error. It says assignment to constant variable. Note, however, that this does not work for reference value because they are tricky, right? If I have an array and I mutate that array and I look at what that array is afterwards, even though I declared it as a const, right, the array is different. And the reason this works is because the variable is still pointing at the same location in memory where that array starts. But it now ends somewhere else. Like I've changed the bits in the chain. That's not really a chain. A list is a chain, but like the bits in the area that is the array, right? So I've mutated it. And this is kind of the thing that can cause bugs in your React code when you end up mutating something. What ends up happening is, as a result, when React does its virtual DOM reconciliation that we touched on earlier, it's like, oh, it's the same array because it's the same location in memory. Therefore, the programmer is telling me nothing's changed. And I'm not going to have to do any work here. And if, in fact, something did change, but you did it in a mutable way, React's not going to know about it, and you're going to wonder why things aren't working. So the same can happen with objects. The object is a kind of like a structure in memory. It's similar to an array in that way that it kind of has a starting point in memory. And that starting point stays the same even if you mutate part of that object. And as a result, even though you declare it as constant, and indeed this thing is not being assigned to something else, the composite value that it represents has changed. The const doesn't work for that part. It only works for, like, think of it as like the top level of your data. It works for that. So if you're using TypeScript, they have a not confusing at all thing called as const that you can kind of append to your variable declaration, and TypeScript will do checking there to say, hey, you can't actually call push because it does not exist on read-only arrays. So TypeScript has a type definition for arrays, and it's got a type definition for imaginary arrays called read-only arrays, which don't actually exist in JavaScript. And I mean, they do if you call freeze, I think, but that's complicating things. And it'll error out when it does its type check. Same thing for objects. If you create an object as const, it's going to moan at you with a slightly different error code, but it's basically the same energy. Okay, so how are you supposed to get anything done if nothing is allowed to change, right? This is similar to that feeling of like, okay, so if I'm not allowed to do any effects, what's the point of programming at all, right? Like I'm doing invisible maths in my processor and it gets warm, and maybe that's useful to warm my room somehow. But like, how is that practical? Like, why would anyone want to do this as a working programmer? So what we do is, of course, things do need to change. We do transformations and operations on our data. So the way we do this in functional programming is, instead of mutating a value, we create a new one, a new value that is usually very similar to the original value. It just incorporates the change at its creation time, and is then we don't touch it anymore. Kind of like sealed. Like we don't go back and change things. We just make new ones, right? So that may sound like it's very wasteful and very slow. I mean, compared to a handcrafted, mutable imperative algorithm, yeah, it's going to be a little slower. But in most cases, that's not really going to matter. So my advice generally is assume that reasonable code runs reasonably fast, and worry about performance problems when you're profiling of your application, not some isolated piece of leet code. Your actual application tells you that you have a performance bottleneck somewhere, because 90% of the execution of your program is spent in 10% of the code. And you really don't need to worry so much about performance everywhere. I'm not saying you should never think about performance, but I'm just saying you can be intelligent about it. So yeah, the example here, we have an existing list. If I concatenate that list with a number, then I will get a new list. This particular function doesn't mutate the original, it just returns a new array. So then I have two lists. If these lists contained objects instead of numbers, then these would actually be the same locations in memory and the same objects. I wouldn't have actually copied the objects. And this is what I meant with structural sharing. So when you're doing immutable data, you're actually not keeping all that much old data around. And you might say, okay, cool, but like, this list is still here, and what if it was slightly different? Like, what if I had removed one and added a new one, and there would have been this object around? And like, well, over time, I stopped caring about the first one in my code, and it gets garbage collected. So it's really not using that much more memory than before. And you can do the same thing with objects, where so what I'm using here is the spread operator. Before the spread operator was there, you could use a different function called object assign. As long as the first argument to that was a new object, you would get a new object out of it, because it is mutable. But if you did it with a new object, then same difference. So yeah, you can change it that way. You create a new object, you spread it in, you say, okay, cool, create a new object with the properties of John, but overwrite the first name property. And there you go. Now I made a change. So how does all of this make your React code any better, right? Turns out React is already functional programming, and you've been doing it all along. Like I said before, React has done a lot to kind of by osmosis put this into the mainstream. And because of its clean kind of API surface with the rest of the world, it can be a little bit orthogonal to, you don't have to do functional programming to use React, even though it's functional programming. And this is, you might hear some people discussing, for example, object-oriented programming versus functional programming online. And usually someone comes along and says, you can do both. And that's 100% true, you can. They're not really in opposition to one another. They're orthogonal. You can do both of them. Personally, I don't see the need to do my object-oriented programming if I can do functional programming. But if you want to, you can. So you may sometimes have struggled with subtle bugs. Let's say if you've got some state in a React component and you are not using an updater function to update the React state. This can sometimes lead to state inconsistencies, such as a state that is changed and then changed again a second later by another update that didn't know about the first update. It was using a stale value to do its operation. You may also get performance issues if your component re-renders needlessly, or worst of all, sometimes you can have your browser seizing up as React gets caught in an infinite update loop. Sometimes React will say call stack exceeded or maximum component depth or something exceeded, and sometimes it won't. Sometimes it'll literally freeze your whole browser and you won't get an error message, which means you don't get a stack trace because it just got stuck. You have to figure it out without any breadcrumbs. Okay, so there's some practical example of this. Let's look at a set state function that does not use an updater function, right? So let's say we have some state, just is it open and set open, and we create a little function that does a specific thing, it toggles it. And do you see how this function depends on this variable that is not here? It's not specified as an argument. This is not a pure function, right? And as a result, now it becomes more important when this function is run versus other things. And it may lead to different results because of that. So you may sometimes have these problems. If instead you did this, where you used the updater function pattern of the set state part of the use state hook, that way, instead of just giving it a value to set the state to, you give it a function. That function will get called by the set state function. And it'll say, hey, this is the current state. What do you just give me? Use that, do whatever you need to do, and give me a new state back. So that is not only a pure function, it's actually kind of a higher order function, because it's a function that takes a function and calls that function in order to get a result. So that's not just better because if there were multiple operations happening on this state, React keeps track of them, does them in order. It'll make sure that if something else changed the state, this value that gets given to this handler here is updated before it gets called, which may not happen with this operation because this might be stale, might have been changed in between. You don't have that logic problem. And even better, you can actually memorize this function for performance gains, which is not possible with the first approach, because if you did it, you would still get the same logical errors. And if you were using the ESLint plugin for the rules of hooks, which you totally should, it would moan at you. It would tell you shouldn't do that. So definitely use that because it'll help you with this kind of tricky stuff. It's a little bit annoying to get used to in the beginning, but I found personally that linter really helped. There are opinions about whether or not you should memorize these functions unless you have a good reason to do so. You'll see, for example, Ken C. Dodds, who is very clever and has written a lot about React and performance, says you shouldn't do it unless you find a need. On the other hand, sometimes I find I lean towards use callback and use memo and react.memo sooner rather than later. Not really so much for the performance aspects, because usually React's plenty fast, but more so that it becomes easier to reason about when my component's going to re-render or not, for the most part. So yeah, being consciously aware of the immutability of your data will avoid bugs in your rendering, and be especially careful to pay attention to compound values such as object and arrays. In the resources slide of this talk, I have a link to the Redux documentation about immutable update patterns. That part of it is not specific to Redux; it just happens to be there, and that can be good reading if you're wondering. Okay, cool. You showed me how to do a toy example, but like in my day job, I have more complex data to deal with. How do I do that? And there are answers for you there. So secondly, if you use this approach of using these smaller functions and separating that logic out rather than one thing and composing those together, it'll help you manage the complexity of your React components. Because I certainly find, unless I'm quite disciplined, the amount of stuff I can do in a single component can balloon before I know what to do. So keeping in mind to keep these things small and componentized, each function does just one thing, and compose those together helps me manage that. So then I have a space where all the logic happens in their individual pieces, and then I have a space where I kind of put it together. Like a lot of functional programming feels like you're just assembling pipelines for the data. Right, so it's my hope that by exposing you to these concepts and techniques explicitly, React's programming model will feel more natural and comfortable. If this did pique your interest, you may also want to dive deeper and learn about algebraic data types. So in JavaScript, for the most part, an array is an algebraic data type. It has a map function. We tend to think as a map function of like loop over this array and give me a new array with a transformation. But it turns out map is something that can be done for other types of data structures. It's kind of a way of saying, hey, here's a function, you do your thing with that function, right? And what an array does with that function is it runs it on every single one of its elements. But there are other data types that might do something different with it. And what's nice about that is it means that when you're creating functions that do functionality, you don't have to care about the structure of the data types in order to operate on them. You can just worry about how to transform a string or something. And what algebraic data types give you is kind of like a universal API. And they allow you to write simple functions that can be reused in far more situations than you would ever think. They're very cool and very interesting. Another interesting thing is functional reactive programming, which incidentally is where the React in React comes from. Functional reactive programming is a way of programming where you consider everything as a series of values over time, right? So we have, let's say a number is a simple value. It's a single value at a single point in time. An array of numbers is a series of values at a single point in time. You might have a series of numbers at different points in time, or a series of arrays in different points in time. It's like another dimension to this kind of thing. Functional reactive programming helps you deal with that kind of in the same way. Like they also have concepts like maps, etc., and so forth. So this is really useful for like interactive processes. It actually grew out of digital signal processing. So yeah, you can Google that one as well. Here are some resources. I've given slides to Mike, so hopefully he'll put them up on Meetup. So I'm not going to go through these too deeply. There's the mutable update parent, as I talked about. Lodash, everyone's favorite utility library, is actually by itself the default one, not well suited for functional programming. Remember I spoke to you about how functional functions are curried, and we are very concerned about how many arguments they have. And also, I didn't mention this at the time, but what that means is that the thing we actually want to operate on has to be the last argument. Has to be the last one, because otherwise we couldn't create this kind of like pipeline where we kind of line up the, imagine every function is like a needle that has an eye. We line up all the eyes and the data just goes through it and it gets transformed. So you have to have the thing that needs to be operated on last. Lodash/fp is from Lodash officially, but they're changed. These functions that they have fixed arities, they're curried functions, and the thing you operate on is the operand. The final operand is at the end. That's the last argument, so it helps a lot. Then there's Ramda, which is even better, but it might be harder to convince your teammates to work with it because it's unfamiliar. What's so great about functional programming anyway? This is a great blog post by a guy called James Sinclair, who's recently released a book about functional programming. Composing Software is another, in this case, free to read online book about functional programming in JavaScript by a guy called Eric Elliott. Professor Frisby's Mostly Adequate Guide to Functional Programming. So this is a Git book you can read online. Skulk, that's how I got into functional programming. I had heard about it before in the spec discussions about the API of promises when they were being standardized, and someone in there was super salty and they pointed to this thing called Fantasyland, which is a spec, a tongue-in-cheek name because somebody accused them of living in a fantasy land, a spec for algebraic data types in JavaScript. And so that's the first time I kind of heard about functional programming, but I was like, okay, cool, there's just internet beef here. I don't know what's going on. But this really opened my eyes. Classroom coding with Professor Frisby, it's by the same guy. It's using functional techniques in a React application. It's 3 YouTube videos. Functional light JavaScript. Imagine you think it's kind of cool, but you're like, yo, these people have drunk the Kool-Aid. I don't want to be that hectic. Also, I have teammates who are still on planet Earth that I have to work with. This is for you. Functional light JavaScript is written by @Getify, and it's free to read online. And it's kind of like, yeah, just the bits that you like kind of thing. And then I'm not familiar, if you're familiar with the awesome lists, which are just repositories of awesome links and resources about stuff, this is one for functional programming in JavaScript. And that is the end of my talk.
That was really
Thanks so much,
great.
Xandor.
Yeah, I have a ton of questions. Also, there's a ton of questions in the text chat. I know I'm getting ready for the text chat to get super spicy now, as it always does when you talk about functional programming. But I'm hearing a baby cry, so Mike,
I'm on it. I got it.
I'm back in a second.
Okay, awesome. So we got a question from Luca. He's asked, if functional programming has all these benefits, why is object-oriented programming used so much?
That is a great question.
Before you answer, sorry, someone in the chat popped up about this, and they said it's simpler to understand and model concepts in. And I thought you might be able to address that while you had it. So, like, let's just include that. Super blah. Had some thoughts on it as well. But yeah, I'd love to hear your thoughts.
Okay, so personally, my opinion is that object-oriented programming is not simpler. I believe in its desire to encapsulate state. It instead ends up scattering it everywhere. But there's still all this kind of like implicit relationship between that state. And the reason for that is that in order to pass a message in object-oriented programming, you have to have a reference to that object, which means that one object needs to be part of another object's state, unless it was given that reference at creation time. The only way you can do that is by creating a call hierarchy. Not an inheritance hierarchy, a call hierarchy. However, a call hierarchy suffers on a long enough timeline from all the same problems as an inheritance hierarchy. And this is because on a long enough timeline, all hierarchies are brittle. You may not have quite as many issues, but you will do that. So in practice, what ends up happening, because you end up needing to do massive restructuring when some component down in this part of the call hierarchy needs to send a message to this part of the call hierarchy, because they can't at runtime technically have references to each other, because doing so would be sharing mutable state, which leads to complexity. You have to instead restructure your application to bucket brigade these messages up to your God object and the constellation of minor deities that it manages, that so on and so forth. And in practice, what ends up happening when there's deadlines, everyone goes, screw that, and they just do the mutable sharing of state and do that for a few years. And in my opinion, with object-oriented programming, you're kind of damned if you do and you're damned if you don't. Yes, I believe that if you have a crack team of really experienced object-oriented programmers who have drank that flavor of Kool-Aid and they're quite disciplined, that you can end up not tearing your hair out. How many times do you end up in that team? Not often in my case. Why is OOP so popular, though? The answer to that, in my opinion, is Java. It's because Sun Microsystems is very good at marketing, especially to developers, and it's because it promised develop once, deploy everywhere. It enabled rapid application development, building these GUIs with objects. It's really the tree structure that made it so ergonomic, but it was a hierarchy of objects that they ended up using to do that. And in my opinion, that's why there's a talk online called Object-Oriented Programming is Bad by a guy called Brian Will. It is a opinionated, divisive talk. People either love it or hate it. You can look it up and see what you think, but I think he makes the case quite well. Having said that, I am not anti-OO, I am pro-FP. I'm not here to cause fight. If it works for you, and I know it does work for some people. For example, some people love working in Angular, which has a much more OO way of thinking about things in terms of how things are structured. I actually do also think, so I tend to think, I make this joke that Angular is, and again, this is a joke, don't be offended, anyone, if you like Angular, that Angular is a front-end framework made by back-end developers for back-end developers. But there's actually a grain of truth in that, which honestly, if I had to advise a client, if I had to advise a client who has a team of C# or Java developers that are mostly back-end devs that suddenly need to build a front-end, I would tell them use Angular. Because so much of how that is structured and the kind of norms and concepts will be familiar to them. That like learning this whole new paradigm while you've got to get stuff out the door wouldn't be useful. So the thing is, one of the other things that React did in the front end is it encouraged this unidirectional data flow, right? You make a change, you fire an event, that event gets caught by something that changes the state triggers a view update. Unidirectional data flow. And those triggers can come from many different places. They come from the user doing stuff. It can come from a network request coming back. It can come from a timer finally ticking off. It can come from a WebSocket sending something to you. It can come from a push notification. It can come from some event. The user did something with their browser, or the OS changed its thing by the time it went from light mode to dark mode, whatever have you. So all of these things can happen. And a web page is like a long running process where these things all happen. And again, the order in which they happen can, if you're doing things imperatively, change the outcome. On the back end, most of the time, you kind of have a unidirectional data flow by default because it's a server. It's just sitting there, it's waiting. Like, give me questions, right? So you send a request and it says, cool, I'm going to handle this request. And it goes, takes the request from the API, or if it's old school, from the view or whatever, and it like goes and takes it and it talks to the database and it gets an answer and it passes it back, and it just goes in and out and in and out and in and out for every request. And each request is kind of like its own little universe. It doesn't really interact much with other requests other than in the database, which usually is an SQL database. And it has these kind of like transactions and ways to isolate these things from stepping on each other's toes. You don't have that in the front end. And that's why I think React is so transformational, because of its unidirectional. It forces this unidirectional thing.
So medium take from my side there. I think it's also partly academic. If you go and study comp sci, you're going to learn Java. You're going to get comfortable in OO. and kind of inherently, because it comes from academia, and a lot of people that end up in our industry have been through those steps. It's what they're comfortable with. And like people often say to me, like, what is the best framework or the best approach? Like trying to decide between taking an OO or functional approach. Go with what the team knows best. Like that's really what matters at the end of the day.
That does matter a lot, but then you have people like Silicon Valley investor Paul Graham, who was like, screw that, we're going to do ViaWeb and Common Lisp and outperform all our competitors, because when they bring out a feature they worked on for months, we can do it in 5 days because we're using Lisp. So it's funny how very few companies he actually ends up investing in. And he's famously the only computer programmer that actually became rich using Lisp. It's the joke, right? But that was his thing. It's like there's actually I think an essay he wrote. He also has strong opinions, and he is a bit of a divisive personality. But he wrote an essay called, I think, "Beating the Averages," where he talks about like how these choices really matter. The other part about academia is like maybe but it's not really the academic part of academia where you end up learning Java, because what academia is doing is Lisps and Haskells and OCamls and Idris and Eiffel and all these other kind of languages that are cutting edge, that are predominantly functional programming language, and have been for a long time. I mean, even the Lambda calculus, which all of this is based on, started from Alonzo Church, who was a mathematician. So I don't think it was purely the academic. So there's different kinds of academia. There's the like undergraduate bachelor's degree. Yes. They do a lot of Java,
that's exactly what I'm talking about, and that makes up the vast majority of our industry, right?
Yes.
Yeah, and there's like the software development diplomas and things as well. But like from my side as well, it's we also shouldn't talk about OOP as if it's this kind of monolith. Honestly, I would make a very big distinction between OOP, like the original object-oriented. Let's call it triple OP, original object-oriented programming, kind of devised by Smalltalk and so forth, compared to kind of this specific version of OOP that kind of the C# and the Javas and so forth have been pushing, which is much more based on inheritance. Even though the initial almost like Gang of Four kind of patterns and so forth actually advised against using inheritance as far as possible. There's kind of through some type of magic trick, like kind of the Java community and the C# community and so forth have convinced people that inheritance is the core of OOP, whereas it's actually, I don't even want to get into it, but there's different flavors of OOP as well.
Incidentally, cool that you mentioned Smalltalk, which is the second OO language. The first was Simula, but that was not general purpose. That was to simulate things. So self, the bit that JavaScript got its object model from, was a Smalltalk dialect.
Yeah. No, it's it's like, and there's also something to be said for popularity. Doesn't necessarily like there isn't necessarily always a kind of a direct correlation between like also McDonald's. You wouldn't consider McDonald's kind of the pinnacle of like the culinary experience. But it's by far the most popular. Like, I'd be curious how much of the meals consumed today, what portion of that was McDonald's meals. So like we should also be cognizant of that. Just because something has a lot of ubiquity doesn't necessarily mean it's based on quality alone. There's some really great questions.
But ubiquity is its own quality, right? So if you're choosing a language, right, you have to weigh things up. You have to weigh up, okay, even if the language at its core is not quite what I think is best, there's a balance to be struck, because if there's the quality of ubiquity, then it means there's better tooling, right? It's like choose your hard. there's parts of it that are going to be hard. Like,
that is true.
And what's harder depends on the context. It depends on who your team is. It depends on what you're trying to achieve, what constraints the project is under, how long it's supposed to last, all sorts of things. And even then, none of that is science. And you kind of just got to do it by, you try and do a little bit of research, but like at the end of the day, I think it's a gut decision that you end up making. And there's no way to know if you were right or wrong about it, because there's no client that's going to pay you to do the same project twice in a different way to get exactly the same result, or to try and get exactly the same result, right?
Yeah, and it's interesting. So you mentioned James Sinclair. So I recently read his Functional Programming for Skeptics, which is an amazing read. I can highly recommend it. And I love the subtitle. The subtitle is something about like leveling up your code without alienating your team, or something like that. Which, and like, I appreciate how much of the book he spends talking about kind of this tension between if you, and I, actually, as someone who drinks the functional programming Kool-Aid quite hard, I do see a lot of times when people are introduced to functional programming for the first time, they're just like, I'm going to curry everything in JavaScript, and I'm going to pipe everything, So, and like, I can imagine like a lot of teams are like, where did this guy come across this absolute madness? Because there isn't necessarily a distinction there in terms of, it's that whole thing about code is primarily for humans and secondarily for computers. But yeah, like, there's some great questions in the text chat. I would hate to kind of go on my own tangents. And I think the best one, like, I'm just seeing it right here in front of me, is, what are your thoughts on RxJS in React?
So I mean, I have used it before. I used it with, I don't remember exactly what. Like, I enjoyed using it, but React kind of already does a lot of that kind of stuff itself. Like, unless I were trying to compose and do complex logic that I would otherwise have to reach for Saga's view for, right? Because Sagas is the same logic as RxJS. Like, it has the same stream operators, right? Take, until, like, wait, all that kind of stuff. And for me, that like matters if you're doing a lot of kind of like temporal logic where, okay, how often has this happened versus that, et cetera, then it like, and when the history of things kind of like matters in that way. Otherwise, I probably wouldn't use it, because it's a lot of overhead to get used to as well, right? You have to get used to thinking in that way. And especially if you're not introduced to functional reactive programming. And it's difficult, because when RxJS started to become popular as a result of Angular, of all projects, its documentation was terrible. It was so hard, because it had this like API reference, and that's kind of it. It had this ESDoc, I think it was ESDoc, auto-generated API reference, and that was it. Like, it did not set the scene of like, what is the philosophy behind this approach? Why does that matter? Like how are you supposed to look at things? It just said, here's a bunch of new tools, without telling you how you should use them to build stuff. And I think that's hurt its adoption a little bit. I think it can be a good fit though. But again, you have the same problems as, like, I think even stronger than doing like a little bit of light functional programming with in terms of ubiquity, like how much of your team understands RxJS, right? And are going to have the time to learn that.
But I think the trade-off for me personally, I've used it in a couple of projects, and like, for me, when you pull it in, there's already kind of a baseline of complexity. Like, either you are like writing your own helpers to manage those things, or you're using RxJS. So like, it's not as if you're kind of in a space where you have a straightforward app, and now you're, well, I guess people do that, but like, where I would pull it in, you've already crossed a specific complexity Rubicon, and like, it's like there's no going back. I've had a lot of success for it when there's like a lot of like debouncing happening, like kind of those type of things. A lot of like kind of interactive specific calculations being happen. Like, okay, when to fire this request, but maybe if this request is out, like still like outgoing, don't do this one just yet. So where you have a lot of like that type of stuff.
Yeah, where the order of interaction of things can matter, and the timing, the way they interleave. Like if you need to have a disciplined way to reason about that, stream processing will help you. Whether that's RxJS or Bacon or there's a bunch, doesn't really matter. RxJS is certainly the biggest name in that space. And also one thing that's nice about RxJS, it's the JavaScript version of reactive extensions, i.e. there's libraries that follow, as far as is practicable, the same API for different language ecosystem. I think it started in Java, if I recall.
There's also one that's specifically like catered for offline first apps as well. That is built on RxJS. There's some great like extensions on top of it as well. But yeah, like if like maybe a caveat is that if this is the first time you're hearing about RxJS and it's not solving a problem that you're not having, stay away from it. As with all tooling, like if it's solving a problem that you're having, you will end up using it by just a quick Google search, because you'll
There is a cool talk and essay called A General Theory of Reactivity, right? By some guy at Netflix. His name escapes me. And it's great. So if you want a little bit of an introduction to, and he uses JavaScript examples to what functional reactive programming is about, use that. Also, quick little soundbite. The largest programming language in the world is Microsoft Excel. Very few developers actually know it. And it is a single order functional reactive programming language.
There you go. Yeah. So just on that note, maybe this is the thing that kind of broke the camel's back. I need to head out. I'm going to be having load shedding. I should have had load shedding 2 minutes ago. So I'm just going to say goodbye to you guys. Mike, can I just trust you to kind of run through some of these comments? I think some of them are phenomenal. Some of the questions I would hate for it not to be discussed.
I have load shedding as well, but I have backup power, so I'm good to go.
Yeah. All right. Cool, guys. Thanks so much, Xandor. This was amazing. And
Thanks for having me.
Hope to... Yeah, no, sure. And I think you're doing this exact same one at the Node.1.js as well. I saw you on the speakers list.
Yeah, so it's not... I don't need to talk about React in that one. I might, but since it's a Node conference, I might.
Yeah. All right. Yeah, I'm looking forward to that. I'm also speaking at that one. And Mike, you're also speaking. All three of us are speaking. Hey!
I think Ben's speaking as well.
The gang's back together again.
The boys.
Cool. I will chat to everyone soon. Thanks for everyone that tuned in. Thanks for all the great discussion in the text chat. Cheers, guys.
Cheers. On the note of RxJS, there's that front-end benchmark website, Krausest. I always found it absolutely fascinating that RxJS is more performant than hooks in their tests. It's like minuscule. We're talking a 5% difference, but it's so interesting to me that it, like, you wouldn't think that it's a natural fit for the paradigms in React. It's left me curious.
So, yeah, I mean, React has a lot of internal logic around batching, and it does checking, and there's all sorts of stuff going on. Also, benchmarks, to develop meaningful benchmarks is really, really hard. And this is why I mentioned earlier, profile your actual application. Don't profile is a for loop quicker than an array map, because it is so difficult to create a benchmark. Because when you try to isolate a little piece of functionality so that you can test just this one approach versus another approach kind of thing, modern JavaScript engines are so good at optimizing code that in many cases, like, one of the things you tested will seem like astronomically faster. And the reason why is because the there's actually no useful work being done. So the compiler just decided, okay, we're just going to optimize that whole thing away. The operation you wanted to benchmark is actually not being done at all. And it's and the thing is, even if you do a test one day, like that may not be the case the next day, because the way these things happen are always changing. Don't trust micro benchmarks. Trust a benchmark of your application, ideally with production data.
For sure, like synthetic benchmarks are just that at the end of the day, and like they need to be taken from the context in which they're done. But for example, the benchmarks that I'm talking about, they run multiple benchmarks, and they they get rid of the bottom however many percentile and the top however many percentile. But some of the examples that they do here is creating 1,000 rows, replacing 1,000 rows, partial updates, updating every 10th row out of 1,000 rows, selecting rows, swapping rows, removing rows, etc. So while it is synthetic, it's at least getting aware of the V8 engines optimizations and like handling hot things and stuff being cached and that sort of stuff. So of course, to be taken with a grain of salt, like you say, for me, it's the same thing. Premature optimization is the enemy of done. I don't think it's really something that we should be spending much time on, even as someone who's worked on projects specifically for feature phones. I don't really think it's ever most of the time, if you're running into performance issues, you've probably done something wrong rather than, you need to do like micro optimizations.
Yeah.
So that's a whole other thing for me, but it's fascinating that like RxJS, which is something that feels very foreign to React to me. How long does it take for the backup to kick in?
Oh no, so the backup isn't for the
so you're on. Okay, awesome.
Yeah, and there's some lights in my house that are powered by this backup, but not these lights.
Well, you still look good. That's the
there's a ring light. I did power that one.
Right. Okay, so there's a couple more questions. Let's dive in. I am Kiko has said, Xandor, I've noticed a few projects I've joined the usage of Ramda for pipeable functions and currying despite the steep learning curve. How do you evaluate when to use such a library?
Right. So again, it's familiarity of the rest of the team. Also the context in which that project is going to survive, if it does survive, right? Because it's very unlikely that the same people are going to be working on that project for its entire lifetime. So that code is going to be inherited. So you don't even have to worry about the team today. You have to worry about the team next year or the year who ends up inheriting your code. Now, I don't think you should necessarily decide not to do things just because they might not like it or something. What I mean is you have to consider the context of the organization who you're building it for. Is it an internal thing? Then who's going to end up getting it? Do you have a kind of organization where something gets built and then it gets put into like maintenance mode and a team of junior developers end up having to do it, or a team of actually mostly old school ops people who are better at Bash than at JavaScript end up inheriting your application? So you have to consider all of that versus things like delivery pressure. Because if there's a lot of delivery pressure and the current team does understand it, then it can speed you up, right? Using something familiar is always faster than using something that's not, but I do believe, especially if that thing is functional, there are indeed inherent speed gains to be had, because remember that bit about the fewer bugs and all those other benefits, right? So once you've gotten over the learning curve, right, which, because it's conceptual, whether you're using Ramda or Lodash or a different programming language, as long as it can do functional things, it's kind of once off, right? The conceptual part is the hard part. It's not the specifics of a particular library that you end up using to do things functionally, for the most part. So yeah, you got to kind of weigh it up. And again, it's hard to know if you made the right decision or not. I would consider the appetite of the organization to invest in their developers. Maybe the CTO likes functional programming. I once worked for a client whose CTO was somehow not a coder, but was learning Haskell. And we actually ended up first getting a bunch of interns from We Think Code and Musi, and we hired them, and I taught them how to program functionally. And I honestly actually believe that the more junior you are, the easier it is for you to grok functional programming, because you don't have to unlearn all this OO stuff. You haven't done it for years. Also, if you're a senior developer and you've been developing in OO for 20 years and you're making over 100K a month, the last thing you want to feel is like a noob. So when you and functional programming is enough of a paradigm shift that you do feel like a noob and everything is hard. And when you're that senior, few things are that hard for that long in your life anymore. And especially not things that are considered foundational. Like you might have a hard time putting up a service mesh or something, but like and understanding how that all needs to fit together, but not something where it's like, yeah, this is how you work with an array, right? That's not what's supposed to be hard for you. So I think that's part of why some people, each other. Yeah, I think some people struggle with that, and it's just a lot of it, right? It's and then the code is so dense, which is what makes it hard to learn. But that is the superpower once you're familiar with it. Like, I don't actually have to care about all the details of all this code. Like, I just know what it does already, and I know it every time. Like, I know what a map does; it'll always do the same thing. Whereas if I look at a for loop, and it probably does what I think it does when I glance at it, but I don't know until I really read every single little bit about
context,
like, what's the counter and the index and everything else, and like I can't be sure until I've read that in fine detail. But with a pure functional approach, it does the same thing every time. No matter.
So I'm going to be super selfish and chime in with one of my questions here. You spoke about map as a function on different data types besides array. Can you elaborate a little bit? I'm so curious.
All right. Okay, cool. So the way the classical example and the one that I like is this. It's a data type called a maybe. It's sometimes called an option or a result, but a maybe, right? So an array is a way to deal with the structure of a collection, and a way of dealing with the structure of a collection of things. Whereas a maybe is a structure for dealing with the possibility of nothingness, right? You might or you might not have a value. So where an array, when you pull map on an array and you give it a function, it says, okay, cool, my structure is to be a collection, so I'm going to do this function for the collection. What maybe does is it has inside of it a value or not. It's kind of like Schrodinger's value. While you're dealing with the maybe as a data type, you don't know whether it has value or not. That's the point. That means you can write functions where you don't have to do a null check or a check for undefined. Like you just, if you have some logic somewhere where, let's say you need to do an operation on a string, but that string might or might not be there, right? So if you were to do this conventionally, imperatively, you would have to go like if string, then do thing with string, right? And else just return the original thing or something. So what happens instead when you have a maybe, at some point you put a value into the maybe, right? But when you write your string manipulation function, you don't have to care about the possibility that there's no string. You just assume the string is there and you give it to the maybe. And you say maybe.map, here's my string manipulation function. And the maybe goes, do I have a value, yes or no? And if I do, then I'm just going to run the string on it and I'm going to return another maybe. And if I don't, I'm going to do nothing. I'm going to return another maybe. And at some point in your program, you do need to collapse the wave function and look inside the box and you call, there is a way to get that value out. But all your business logic, where you're composing these little bits of things, don't have to care about the null checks anymore.
I was going to say,
and what's really cool, if you suddenly had to do the same stuff to an array of values, you could just take your composed pipeline function and hand it to an array. Whereas if you had instead, for each of those operations, done a null check in like some massive function, and then suddenly your boss goes, hey, so we need to do this with arrays. You're like, yes, that's a lot of work, eh? Copy, paste. Okay, I'm going to change this line, and change this line, and change this line. Whereas if you had done it with a maybe, you just go, instead of maybe.map, you go array.map and you're done.
Okay. That's so curious. Like it feels as though it falls somewhere between optional chaining and promises and combining a then and a catch. Like it's this idea of density that it seems like it's doing a bunch all at once, which is pretty curious.
So the promise is kind of like that, except instead of .map, we say .then.
Yeah, yeah.
Right. So in functional programming, there's usually something called a future that has a dot map.
Right.
And so you say, okay, cool, I have a string manipulation function. And it turns out the structure of a future is that you may or may not have a value yet.
Right.
So you say future.map. Basically, what it does is, cool, when I have a value,
Yeah.
I'll run your function.
Right. That's actually
on
sick.
the thing inside of me.
So maybe, but like eventually.
Yeah. Yeah.
Okay, awesome. So at risk of us going off on a tangent, having fun here, let's just check if there are any other questions. So, sorry, I got so distracted here. So, Gideon has asked, Xandor, did you start off with OOP and transition to functional programming? If so, how long did it take you to change paradigms?
I am self-taught and I do not have a traditional education in computer science. However, the first programming language I learned was C++. Because remember, I was in my glorious GeoCities days making websites, and I wanted to do those cool ass water ripple effects in the images that everybody had. And I found JavaScript snippets online, but I could not find a resource that explained to me how to kind of write my own original code. I couldn't find one for JavaScript. I don't know why. It was just hard, like search engines sucked, and I was 13, and yeah, dial-up internet. So what I did find was a bootleg copy, a digital copy of C++ in 21 days, and I read that. And although I had never written any other C++ than what that book asked me to, it helped me understand enough to actually start writing some JavaScript, despite actually the object models being relatively different. It was enough to get going. So I don't actually have a classical OOP background. However, I have worked on OOP projects, and I just always, I don't like it. I feel like in order to understand one tiny piece of code, I have to understand the whole thing, because I can never be sure it does only what I'm asking it to do. Like, you know, it feels like this Rube Goldberg machine where if I tug on one string, it might like pulls a whole bunch of other things.
You're triggering PTSD for me.
This has been my personal experience.
Have we worked on the same project?
Could be.
Yeah, that's very real.
Who is it? Not Alan K. Gerald. Was Gerald Sussman? Someone said, with OOP, you've got the gorilla banana problem. You just wanted the banana, but you got the gorilla holding the banana, and then the entire jungle as well. And that's because of the way you try to encapsulate state in object-oriented programming is you end up promiscuously fragmenting and sharing the state all over the place, right? It's not actually that encapsulated. It's always a leaky abstraction. And it's been my experience that in functional programming, for the most part, the abstractions aren't leaky. And that changes everything.
And like I feel as though sticking true to functional principles in JavaScript, at least, you can often end up with stuff that's just more simple. You know, you're like, I don't like the idea of, oh, a function should only be like one line of code or whatever. Like, I don't think that that's a healthy approach. But generally, you know, like when I'm writing functional stuff, I name it based on what it's doing. You know, so it's doing one thing and it's doing one thing well. And I find it a lot easier to maintain. You know, that's, you know, sample size of one. Whereas as soon as you've got like, even talking about composition within the OOP space, like it can end up being a different set of challenges and a larger barrier to entry, which is ideally something you'd avoid with a code base. But in either case, like I need to not get on this train because it's a dangerous one, and like,
I just want to make it
valid and fair.
I just want to make another note on if anybody here is a little bit skeptical about my claim that in functional programming the abstractions aren't leaky and in object-oriented programming they are. I posit to you the following. In object-oriented programming, there is a lot of emphasis on different patterns to solve specific, well-known, well-understood problems. We've got the repository pattern, we've got the visitor pattern, we've got all these different types of patterns. And the reason why they're called patterns and why it isn't an npm install library instead is because you have to interpret and adjust that pattern for each specific use case. You have to kind of take your business objects and make them fit that pattern kind of on a case-by-case basis and make a decision about what's best to use every single time. Whereas in functional programming, these algebraic data types we talked about, that is npm install. Like you get a library that has them and has a series of functions to work on them, right? In fact, there's a function called map, and all it does is you give it an object and it calls map on that object, right? So that makes it really easy to call map on anything that has a map. But that's the thing, like, because the abstractions aren't leaky, you can actually just create a library and do that. So food for thought if anyone's skeptical.
Cool. We've got one last one from Eneminim. He says, Xandor, what kind of problems is React created to solve?
It was created to solve specifically the problem back in the day on Facebook, where you would open your messages on Facebook and it should clear the little notification icon in the toolbar. It didn't. That was the initial itch that React was created to solve. But that's another thing where like the order of operations kind of matters, because sometimes it would work and sometimes it wouldn't work, because of the way that like the order of operations matters when you're dealing with like distributed mutable state. And React made that unidirectional, and that's what it was created to solve. So and intent has that problem, right? Again, backends do have that problem, because I may have oversimplified slightly when I said that like it's in and out, each request response, it's in and out. Like some requests are advanced and they do a little more, right? But the scope of like the lifetime of a context of things living in memory is still naturally a lot more limited in most backends. Many exceptions. I'm not making a blanket statement that's always true, but I'm making a generalization that I think is generally true. And whereas on the front end, your app may live for 6 weeks until Chrome updates and forces an actual browser restart. Maybe the rest of the time, the user just pins the tab and like hibernates, wakes up and hibernates, and wakes up and hibernates and wakes up. And that whole time, you never flush the state of things, right? And what React does by this unidirectional model is kind of like every time you go through that cycle, it's kind of like a flush with a new starting point after that. Not a blank slate. It's the state from last time, but it does make that happen that way.
Yeah, I think you make a great point that like things are very, very long lived. I mean, if we look at like a regular backend call or like some sort of function on the back end, we're generally looking for it to compete, or I'd hazard a guess and say 95% of functions are complete within like 200 to 250 milliseconds. Mm-hmm. Anything that takes longer than that is very, very, very scarce, and it's generally solved with a very different like a very different approach. Like we're looking at messaging queues and a whole bunch of different paradigms there. Whereas, like you say, an average single application, like if we think how long, like if you open a YouTube tab, you're sitting with this thing open, you're doing like comparatively bizarre, messy things. And yeah, like it's easy to dirty things up. I mean, as any Windows user can attest to, generally a reboot fixes 90% of problems.
Yep.
And if you think like we're expecting the same from a browser, that average Joes like us build apps in, like we're probably not as good as the guys working on Windows itself.
So I think, well, actually, so longer I work in this industry, the more I believe that these products from these massive tech companies were slapped together by interns. A long procession of interns. I am. This is hyperbole. Mm-hmm. In practice, it's people fresh out of varsity that stay around for a year or two. Not quite interns, but close enough. They are, for most of their people, like there's a huge amount of churn that ends up happening. People know that it's hard work. People know that it's going to be a little bit of good pay and it's good for their CV and they're going to get some good experience. And a lot of them aren't there forever. It's similar to the advertising industry. A lot of people work for the big agencies just to get it on their CV and then they leave. Yeah. I don't want to talk about advertising though, because then it'll trigger my PTSD.
I think that's a great note for us to end off on. I think we've addressed all the questions. Xandor, thanks so much for your time. It's been really insightful. As Skulk said, it's you got some really interesting take on things, and it's you got a surprisingly extensive background. It makes me feel as I need to do a bit of reading to up my game a bit, so that I can rub shoulders with peers. But yeah, I really appreciate you taking the time to prepare this talk and address questions and share some of your experience with us.
Oh, it's a pleasure to be here. Thanks for having me. I love doing this kind of stuff. If anybody has more questions or wants to chat, again, my socials were at the beginning of the slides. Michael, you're going to put those up on Meetup?
Yeah, I'll pop them on there.
Yeah. All right.
Awesome. Cool. Have a good one. Thanks everyone for joining. Cheers. Hope you get power soon.
Yep.